This is a video about subnetting. Some of it's a little bit traditional, some of it's a little bit non-traditional, but we're going to kind of go over how subnetting works in an IPv4 network. Right, so here's the basic deal of IPv4, right? While it's on the way out, a lot of companies still use it. A lot of companies haven't made that transition to IPv6 yet. So while we're still working in IPv World 4, it's good to know about what you've got going for that and how do you actually use it. So computers, once you get past that physical connection where one wire goes into the computer, one wire goes into the switch, right? You literally have two addresses on your computer. The first one is the MAC address, right? And that is your hardware address, and that is your NIC card and the switch port, right? And that switch port keeps track of all that hardware addressing and what's called an ARP, an ARP table, right? And that's an address resolution protocol table. That's just MAC addresses, port MAC address to NIC card MAC address on a computer. Now the next level up, right, as we go through abstraction and through the OSI layer, right, we'll skip a couple layers here to do this. We go through your IP address, and your IPv4 address is made up of 32 bits of information, and they're in decimal numbers, so your regular numbers that we can all understand and read. So like a standard Class C IP address, 192.168.1.3, everyone's going to get that. Everyone understands what it looks like, everybody understands how to work it, right? But it's actually 32 bits of information. Right, so this is how when you're surfing Facebook, Google, Snapchat, or something else, at some point you'll be ranking through an IPv4 address, whether it's internal to your home network or whether it's external someplace else. The good part about this is that now that we know what these are, we can actually start working with them. So IP addresses, they'll come in certain classes, right? Just like networks are broken up into Class A, B, C, D, and E. Right? So Class A addresses are basically how they broke out the address range when they were designing IPv4. So Class A IP address is from 0 to 127. Class B is 128 to 191. Class C is 192 to 230 to 223. Class D is 224 to 239. And Class E is 240 to 254. Class D and E are really special. Right? They're used for different things, and we normally will stick around in the A, B, and C range for a lot of the things that we want to do. For some kinds of internet routing, we'll use Class D, and then the only time I've ever used Class E was when I was working on a special project that we really needed to make sure we didn't leak any data at all. So there's key things to remember, right? Again, we're going to come back to this. And each IPv address is 32 bits long, but we broke these up into 8-bit chunks, right? So 8 times 4 is 32. So each one of these numbers is called an octet, and there are 4 sets of these numbers. 192 is one set, and it's an octet. 168 is another 8-bit octet, and 123 is another 8-bit octet, and 123. So each of these octets can be a range of 1 to 254 for use, 1 to 255 for subnetting, and then 1 to 256 to make the math work. And this is where people are probably going to get really upset with me, because I need the math. I need the math to work, so I need to be able to use these numbers as intended, and you'll actually find some CISCO documentation that goes through on how to use this, so you can do this in your head. Right? Now there's network bits and there's host bits, and this is something you can just like straightforward kind of memorize, right? So Class A IP address, that first octet is your network. In Class B, the first 2 octets are your network. In Class C, your first 3, A, 1, first, B, 2, second, C, 3, third. All right, so again, if you see Class A, it's the first octet. If you see Class B, it's the first 2 octets. If you see Class C, it's the first 3 octets that define the network. Right? And then the host bits are how many hosts can be behind that. But it doesn't mean you can't break these up into smaller chunks. And that's where we get into subnetting as we go through this. So it's kind of a little bit easier to understand when you kind of take a look at A, first octet, and then your host, right? And remember, 32 octets, 4 groups, and you just add them up, 8, 16, 24. And you kind of approach where that goes from there. So you can actually have 24 bits as your network, and then host, which would give you 255 hosts on that, right? So kind of neat on how that works if you come at it from that viewpoint. So the good part about IPv4 is that it has what's called a private IP address range. So not everything on the network is going to be routable across the internet, and that's kind of part of the process on how we designed this network way back in the day. right? So what they did is they made some private zones, some private ranges. So Class A private range starts with 10, Class B private range starts with 172.16 and goes to 172.31. Class C private range is 192.168.0 through 192.168 through 255. Right, so this private space is where you can build your own network, and you don't have to have your database, publicly faceable on routable on the network. Right, so you have your 1 or 2 or 5 publicly facing IP addresses that then get plugged into a router, a firewall, or something else, and then you can route back into your private network that the rest of the internet doesn't know about and probably shouldn't, to do your company's business without having to worry about having to consume public IP address space to do it. And then there's special IPs. So there's some special IPs out there, and one of the ones I think is the best is your local port, right? Your local host. Right, so 127.0.0.1 is localhost on your computer. So if you ping 127.0.0.1, you'll find out if your NIC card actually works. It's a good self-diagnostic for how is your NIC card working and how is that going. If you don't get any answer back from 127.0.0.1, either your software TCP IP stack is bad, you need to reload it, or your NIC card's gone bad. The key part is that we all call this home. Right, so if you think about Dorothy from the Wizard of Oz, there's no place like home. You ping your local port, you ping your local host, you ping home. Right, and that's just kind of a way of looking at it. This is a great diagnostic tool to find out if it's software or hardware for your local computer. Or on your switch, you can do the same thing for your switch. Right, so Class D IP addresses are also interesting because they're used for multicasting data. So this is where it's interesting because you have Facebook.com, but you have something like 2 billion people trying to use Facebook.com at any given time during the day. And given that, there is no one computer that can handle 2 billion people. So you have clusters of computers, and those clusters of computers are spread worldwide. And we use Class D IP addresses for that. So you can be Facebook.com with a Class D IP address. That will take it from my phone and look at Facebook.com and route me to the nearest Facebook that can take that. And that's how that process works for multicasting data, right? Not just one host, but many hosts used to load balance an entire network. The cool part about Class D is it also can be used to help discourage or fight against denial of service attacks. Right, so if Facebook.com is having a denial of service attack, they can reroute all those Class D via Class D. They can reroute Facebook.com to an internet cleansing center really quickly by doing this, and then route it back to Facebook.com. And again, very quickly able to deal with denial of service attacks because they can be pretty devastating for companies that don't have this process in place to get to an internet cleansing center. The other one is Class E, and I actually really kind of like these because they're used for R&D purposes. On one of the projects I worked on, we actually used Class E IP addresses because we didn't want any data leakage at all for what we were doing. It was really tippy-top secret and a lot of fun to work on. But it was kind of that process where no leakage, we can't route, we only wanted to route among our systems. So Class E was perfect for this, right? And we could have done it in different ways. But we kind of also wanted to play around with Class C IP address spacing to see what would actually go with it and how it would actually work. And we used it, and it was fun, but that's how we used it. It didn't go very much further than that. So CIDR blocks, though, is another way of addressing how you break up a network, right? So quick and easy way. So back in the day, way back in the day, networks didn't have gigabits of RAM that you could tie routing tables into. And routing tables, as the network grew, as the internet grew, got more and more complex. And that meant it sucked up memory space in switches, routers, and computer systems that we really couldn't afford to give up. So they came up with a shorthand, a notation called CIDR, classless interdomain routing, right? And it's basically not just an alternative, but it basically, again, it's just a shorthand for it. So we can save bits, and it's all about saving space in routers and switches for memory, which is really kind of cool. So you can take your whole process and say /29 instead of doing this. So you can say 192.168.0.0.255.255-248. Really then shorthand under CIDR blocking becomes 192.168.0.0/29. We save three spaces. We actually save ourselves 3 times 8 is 24. So we actually saved ourselves 24 bits. And that's 24 bits that I can shove and use some other way inside that router. And it's essentially just a space-saving way of taking care of things. The other thing too is, because remember, we're dealing with 8s, right? We're dealing with 4 octets of 8 for our 32-bit IP address spacing guide. That means if I have a Class C IP address, right, and my subnet is /29, it means my subnet mask is 255.248, right? And you can break this down and then just subtracting 8 and moving things to the left. So if you want a Class B IP address, it's going to be /21 with a 255.255.248.0, and then 10, right, or Class A for 10 would be /13, 255.248.0.0. So you can number walk these, right? You can actually number walk by if you have the same concept, right? IP address for C, B, and A, really similar, right? So if you know C, you can pretty much guess A by removing 16 and then just sliding 2 spaces to the left. And again, once you learn the trick, it actually makes your CIDR blocking a lot easier. You can also go through, and you can find these anywhere. I found this on the internet, just some rando kind of thing that will give you your SmartNet, your subnet mask conversion. So you can kind of see your Class A here is /24, right? So 255.255.0, 16 for Class B, 255.255.0.0, Class A for 8, and it breaks everything down for you all the way up to from 8 to 32 for your conversion for your subnet. And again, these are really handy to have too. You can just tape it to your cubicle wall or whatever. But sometimes we do need to break things up a bit, right? So this is where I'm going to get torn apart by the purists, and I'm okay with that. But sometimes you need to do things by the math, and sometimes you need to do things by the reality. Okay, so the reality is my number stops at 255, right? When I'm dealing with a subnet mask, it stops at 255. But to make the math work, I need to use 256. So as long as you remember 255 is the reality and 256 is how you make the math work, you'll be fine. And there's actually CISCO documentation out there that has this exact kind of math. So sorry about having to use 256, but as long as you remember you need 256 for the math, you need 255 for reality, then we're in good shape. And you kind of see this in here, right? So I need a Class C IP address, I need to make it 4 equal subnets. So this is not necessarily true. There are not 256, but I need 256 for the math to work. So I need 256 divided by 4. And that gives me 50, so this is the number of spaces, this is the number of networks, so 64. Total subnets I need. So count by 64. 255.0, 255.64, 128, and 192. That gives us our subnet mask, right, of 255, 255, 255.0, 255.64, 255.128, and 255.192. Remember, 255 is my reality, but I need 256 to make the math work. Sorry. It works though. Here you go. Let's say I have a Class C IP address. I need 8 equal subnets, right? And some of these are going to look really, really, really CompTIA-ish, right, when you get down to it. Because some of these are actually things you'll see in a lot of CompTIA training for the Network Plus, which is kind of interesting. And you'll see these exact same things, right? I have a Class C IP address. I need 8 equal networks. Well, 256 divided by 8 is 32. Remember, I need 256 for the math. Each network will then have 32, technically, available IP addresses, but that's also not necessarily true because I need to have a gateway and I need to have a broadcast. So really, 30. So each network will have 32 available IP addresses, but I'm going to use 2 of them right off the bat. So my subnet, 255.0, 255.32, 64, and so on, counting by 32. Now, sometimes they'll ask you for your IP address range, right? 1 through 32, 33 through 64, and then my subnet, 255.0, IP address 1 through 32. So we have 8 subnets and their ranges. Sometimes you'll see that when you're dealing with IP addressing as well. All right, Class C IP address. I need 2 networks. So 256 divided by 2 is 128. My subnet mask is 255.0/25, right? Because that's my CIDR block. And then 128 by 25. So my CIDR is 25. All right, so remember, we're counting bits. And we'll go over how to count bits here in a little bit. Right? So here you go, some homework. All right, so I have a Class C IP address, and I need 3 subnets. One with 100, one with 34, and one with 28. And I need to leave some room for growth, right? So this is the good part. I'll leave some room for growth. It means that they don't tell you how much growth they need to have. So what's my subnet and what's my CIDR, right? So I'd play the Jeopardy song right now, but I don't really want to. So I have a class C IP address. I need 3 subnets, with 100, one with 34, and one with 28. So 100 IP addresses, I can just split the network in half, right? So there's my 25. There's my half of my network. Then I need to split the network into 2 more. So 34. It'll leave some room for growth, right? Right, some room, doesn't say. So 128/26 is my CIDR, and then 192 is my other CIDR. And we'll go through how to calculate all this stuff along the way in terms of how this works, right? But remember, we count things, we count bits as we move along here, right? All right. So sometimes we got some stretch homework. So if I have a class A IP address, then I need to split into 4 equal parts, right? I actually used a calculator for this one. And there's calculators all over the place. It doesn't mean that there's not a good one or a bad one, but you can use a calculator. I've just got one out here at calculator.net. So IPv4 subnet, you can break things up, right? I just needed a little 4-host network. Number of usable hosts was 2. Right? Remember, available versus usable, and we'll go over that. And then your subnet mask, right? But this is what I mean by count, right? So each one of these 8 bits, right? 8 bits, 4 octets, right? And this will tell me. So if it's full, if all of these are turned to 1, then it's 255. If it's not full, then we can count the ones. And each one of these actually has its own value when you're counting. So this would be 128. This would be 64, this would be 32, 32, 16, 8, 2, 1, 0. That's why 255 versus 256 is kind of twitchy, right? So if all of these added up, they come up to 255. If you take away, if you add all these up, it would come to 252. So when you see something like this, you automatically know that all of these have been turned on. All of them are done, right? All of them are equal to 255. And again, we'll go over more of this as we kind of go through it. But your stretch homework, right? Your broadcast address, your usable host range, your network IP address, right? And so you kind of go from there. But you can see how they kind of broke up that network here, so you'd be able to do more with it, right? Okay. Even more stretch homework. How do you separate a class B into 4 equal subnets? Let you work that one out. Put your answer below in the comments, and let's see what you come up with. Okay, so why subnet? Why on God green earth would we do this? Well, first of all, we needed to bust things up. So subnetting is a way of breaking up a network into smaller chunks. And this makes a lot of good work for security, right? You're looking at VLANs, you're looking at VPNs, you're looking at guest access to wireless networks. You can now do this without giving an entire IP range to a particular device or a particular group. You can tie things down better by using subnetting. You can actually subnet by department, you can subnet by group. The one I like the best is putting all HR computers on the same subnet and then electronically isolating that subnet using a VLAN, right? Because not everybody needs to know what's going on in HR land. Not everyone is going to be wanting to have access to that, right? The other one is breaking networks into management zones. So if you're in a really big company, and I've seen this with really big companies, is that all of your routing is using Class A network. So every router, switch, firewall is all on Class A for management, and that isolates all the networking. Then each office is on a Class B, and then each department within that office is on a Class C. Right? And again, it's just a way of managing it out. So Chicago can be on its own network, on its own subnet, where you can do this so that San Francisco's on a different Class B, on a different subnet, right? So you can have everything broken apart nicely, either all on the same subnet or on different subnets within the Chicago office, depending on how the network engineer decided they wanted to do this. Pretty standard nomenclature, right? But the big thing is remembering that there's usable hosts and available IPs, and this is the big one, right? So if we go back to our system, right, where we broke out our little guy here for our 200, I have 4 available IP addresses, but only 2 of them are available. And the reason why is because I have to have one for a gateway, one that will get me onto the rest of the network, and then one that will turn around and be used as a broadcast across the board, so I can send a note to every single computer on the network along the way, right? So, always reserved. In general, by nomenclature, by the way we do things, by convention, the first IP address is considered your gateway, and the last IP address is considered your broadcast, right? But remember, I just need 256 for the math. We're generally not using it. So when I'm doing my last IP address, I'm using 255 as my broadcast address on a full-on Class C. All right, so that's the thing to remember. Sometimes I need to do things for the math, and sometimes I need to do things for reality. So here we go, two departments. Human resources and finance. I want those two separated, right? I don't want some human resources giving themselves a pay raise, and I don't want someone from finance changing all of the evals for the end of the year. So even they work together a lot, well, we need to be on their own network. So they share the same Class C range, we can just split it, right? So we can split that into two segments, 192.168.12.1 through 128. So remember, we just need half of that. So for our network, it would be 192.168.129 through 254, and then 0 through 128, right? In reality, remember, we stop here at 255, but remember, I need a broadcast address, right? Big things there. So your network engineer is going to turn this over to you, right? So when you're doing all your documentation, he's going to go, here you go. Or the network engineer is going to go, here's your binary, right? Full on 255, 255, 255, 1. That first one is lit up. So that's 128, right? And the same down here for the network. But we put in our subnet mask of 25, right? Because of 24, 8, 16, 24, all lit up, all ones. And then another one, so 28, 16, 24, 25. That becomes my subnet mask. And you can do this literally. This is how you can count out a quick and easy CIDR, right? So if you're in the middle of a test and they hand you CIDR 29 and you're like, oh, wow, what's that? You can go 8, 16, 24, 25, 26, 27, 28, 29 gets me there. So 0, 1, so that's 4. I get 4. I get, right, usable here, right? And you can count these up. So your broadcast here is going to be 127 because I have to have reserved. My host minimum 1, my host maximum 128 because remember I need my broadcast, right? So host per net I can have 26, 126. And then same thing for the bit, right? As for the other side, right? 128/25, right? But starts at 128 instead of 0. Same broadcast, different broadcasts, a different host min, different host max, and then my host per net 126. And again, it splits it apart, but binary-wise, this is basically what it looks like in terms of how you do things when you're working with splitting a network in half, and this is how your engineer is going to look at it. All right, so let's do the same thing. All right, so let's take a look at this. So what happens if I have to divide my network into 4 chunks? Right, 464 IP addresses per network because I got to divide 256 divided by 4, right? Again, remember, I need 256 for the math. We have 2 things here. One is count by 64, and then the other one is calculating our CIDR block. So if our subnet, right, 4, so I have 255, 255, 255, so 8, 16, 24, and then 128 and 64 are covered in my binary. So 8, 16, 24, 25, 26. So my CIDR block is 26. So, but I have to count by 64. So 0.26, 0/64/26, and so on. So the CIDR block stays the same because I'm just carving this into 4 sections. But this is how it's going to look, right? So we're putting that 1 on. We're going back to our engineering thing. We're going 128, 64. And then we count out the rest of these to make it work, right? So that's how we do this. And again, probably clear as mud. But again, as long as you keep on going, you'll be good to go. So let's say I need to break this up, right? Or go back to what our original was. I need one network with 100 hosts, 40 and 50, with some room to grow. How would I subnet it? Well, we know that our large block is half the network, right? We already know that. So it's /1, so it's 128. So it's going to be /25. And then we would need 2 smaller blocks of 64. So that means I need an extra bit turned on. So it's going to be /26. So I have one subnet, 255.255.255.0/25, and then 128/64 and 192/26 and 26. Because I grew by 24, or by 64. Right? So Class A and Class B networks are the same. We just back out 8, right? So 1/2 of Class A is still 128, but my subnet mask is 255.128 for half of Class IP range. So 8 plus 1 is 9. So my CIDR for this is done, right? Half my class B is still 128, so 8, 16, 17. So my CIDR block is going to be 17 for this, right? We can just shift ourselves to the left as we kind of go through as well to kind of grab that. But remember, that shifting left and that counting of these full blocks is what's going to help you get to your CIDR block really super quick and easy. So again, if you need a quarter of a class A or B, same idea applies, right? As you kind of go through, you can still break it up, and there's your quarter by just using 192. It can be 64 or 192. It depends on where you are with it. I just tend to go backwards on this. So once you know that you can shift the subnet number left and drop a 255 and add a 0, then you already know what your network roots are for A, B, and C. It's really easy to just start tacking on your CIDR blocking. Right? So how does CIDR work into this, right? So we know from our CIDR notation that they're rooted class A and IP addresses and so on, and that we can split our networks up and all the rest of it. That when we take a look at our subnet mask, right, 255, that we want to count these, right? So when we count these, each one of these has its own particular number, as I said earlier, right? So when we're breaking things up by 8s, it's a lot easier to go 128, 64, 32, 32, 16, 8, 4, right? And then count those and add those to get to this, right? As long as you know what each of these little bits represent, it's really easy to get to this for your subnet mask. You just have to remember how these add up on the number line. And it really is just a number line, and each one of these has a process where this is worth 128, this is worth 64, this is worth 32, and so on. If you see the full thing done up, all ones, then it means 255. And as long as you know what the maximum number is, and you know what each one of these represents on the number line, it's just number line counting. And you can do this in your head. And you can do this for Class A and Class B as well to just kind of round out how you want to do the process. And once you've counted the number of ones that are turned on, then you know what your CIDR block is. So your CIDR notation here is 30, right? So 8, 16, 24, 25, 26, 27, 28, 29, 30. 30. Again, just a simple number line, straight up. That's all there is to doing a CIDR blocking. And as long as you know what the positional notation is for all this stuff, and you know how to make the math work, you're good. That's it. That's all you need. So if you do have any questions, though, but feel free to put them in the comments below. I'm really curious to see what you think. I know, again, that some people are going to be really angry with me because I use 256. But remember, I just need 256 for the math to work, right? And outside of that, feel free to let me know what you think. Thanks much. Bye-bye.